Assalamualaikum and good day everyone. So we meet again for this week's lecture. We're going to finish up all the subtopics in the differentiation. We only left 2.6, which is L'Hopital's rule. Okay, this is L'Hopital's rule, and another one is this one, the applications in terms of rates of change in circuit analysis. So rates of change is actually referring to the application of derivative or differentiation that you have learned before or previously. So how can we use it to calculate, right? To calculate the current, or to calculate the current of the capacitor, and to calculate the voltage of the inductor, okay, in circuit analysis. So before we going into this practical part, the application part, so let me finish up first, okay, the L'Hopital's rule. So what is L'Hopital's rule? So L'Hopital's rule is actually a special rule that you can use, okay, or you can employ it in order to evaluate the indeterminate forms of limits. So if you can recall the limits that you have learned in chapter 1, the limits, we encounter something, a condition like this, okay, 0 over 0, or plus minus infinity over infinity, okay. Last time when we encounter this kind of problems, we're going to solve it by using the algebra techniques, okay, the very specific one. For example, factor and cancel method, expanding the binomials, rationalizing method, and so on. You need to refer back to chapter 1 if you already forgot about it, but that's okay. You still got plenty of times to study, so talking about this, so last time we need to use special or very specific methods in limits chapter, but in chapter 2 we learned about L'Hopital's rule, where you can apply this rule, okay, to solve the limit question when the answer for that limit question involving 0 over 0 or plus minus infinity over infinity, okay, and or any number plus infinity. So you can use this L'Hopital's rule. So what is L'Hopital's rule? Okay, so L'Hopital's rule, it helps us to simplify the solution of the limits problem. Okay, so instead of using factor and cancel method or rationalization method that you need to multiply the conjugate and so on, or limit at infinity, okay, that requires divide by high power and so on, okay, by using the L'Hopital's rule, you need to apply the differentiation techniques, okay, in order to get the answer for that. So okay, how to do this? So we need to go into the example. So example 2.11. In this example, we have these two types of questions. Okay, so let's go for the first one, the first Roman here. So if you notice, okay, we have x squared plus 6x plus 9, okay, over x plus 3. If you recall again, okay, in chapter 1 last time, well, if we directly substitute the minus 3 into this, you will definitely get 0 over 0. So last time in chapter 1 we try to we know that these have different or a finite answer, okay, it's not 0 over 0. 0 over 0 or infinity over infinity is what we call as indeterminate form. So we know that this kind of question will have a determinate form, okay. We don't want 0 over 0. 0 is indeterminate, but since we know that this will produce another answer, which is determinate. Okay, and what is that? We need to find out by using before L'Hopital's rule. Yeah, I'm talking about how can we apply this using limit solutions. What you can do is you can factorize it. So x plus 3, so you factorize this one so that you can cancel it with the denominator here. Yeah, so when you got this one, you can have a more correct, you can get a correct answer. Yeah, so this is minus 3 plus 3, so you will get so when you apply the limit, yeah, okay, so when you apply the limit, you'll get negative 3 plus 3 and you'll get 0. Okay, now this is how you solve this question using chapter 1 method. So if the question, if the during the test or final, not final exam, during the test, if the L'Hopital's rule question appears, then you can thankful for that. Okay, because it is very straightforward to answer this. How to do that? So we go to this tab. If I can change the color, yeah, this one. You need to differentiate the numerator and differentiate denominator independently. Okay, what do I mean by that? So if I can write it down again, the question here, limit x approach to minus 3, not a bracket, x squared plus 6 x plus 9 over x plus 3. So we need to this is the solution for L'Hopital's rule. You differentiate it independently. So first we differentiate the numerator. So when you differentiate it, you will get 2x plus 6, and then we differentiate the denominator, you will get 1. So from this, you can straight away substitute the x minus 3 into this. So you will get this one 2 times minus 3 plus 6, you'll get 0. Right now I forgot to write down the denominator, over 1, so your final answer will get 0 over 1. So 0 over 1 is fine. Okay, this is the determinate form, or in other words, you will get 0. So yeah. Okay, again, other indeterminate form, okay, besides 0 over 0 or plus minus infinity over infinity, is actually another one, any number over 0. So we don't want these 3 types of indeterminate forms. Okay, okay, I hope that one is clear. So now we go to the second question. Okay, in second question, I hope this one is already clear to you. So when you direct substitute the x equals to 4 into this, you'll get 0 over 0. So this is the, again, indeterminate form. We don't want this one. So by using L'Hopital's rule, you just straight away differentiate the numerator and denominator independently. So this you will get minus 2. Okay, for the x squared minus x minus 12, you'll get, when you differentiate it, you'll get 2x minus 1. So from here, you can straight away plug in the value of 4 into x, and you'll get 4 times 2 is 8. 8 minus 1 is 7. So your final answer is minus 2 over 7. Well, L'Hopital's rule, okay, my tip is, during the test, okay, you can apply L'Hopital's rule to double check your answer when you need to answer the limit question using limit techniques. Okay, we have several techniques in limit, right? If you can recall it, it's direct substitution or plug-in, and then we also have that specific technique using algebra, factor and cancel method, expanding binomials, getting the common denominator, rationalization method, and then we have limit at infinity and infinity limit. So you can try to apply the L'Hopital's rule in order to check your answer. Okay, if doesn't tally, if your answer using L'Hopital's rule, you get a different value with the answers that you get from the limit solution, it means that your limit solution is having a there is something wrong with your limit solution, so you need to figure it out. Yeah, so that's my tip during your test later on. Okay, now we have an exercise. I already shared the answer for exercise 2.6 in the previous video, week 5 part 2, so you can check the answer for this exercise. You can try to do this by using the L'Hopital's rule. And now let's proceed with the last subtopic, last subchapter, which is applications, rates of change.